I'm going to keep this straightforward because what you really need is a sense of whether this shaker will actually solve the problems you face in the lab, not a list of buzzwords. If you're on the fence about spending a few thousand on a lab shaker that promises precise control and robot-friendly positioning, this review is for you. Link is in the description if you want to check the product details on Amazon. First off, the biggest hesitation most people have when looking at a piece of equipment like the IKA HS260 is the fear of paying for features you'll never use. A shaker can be a workhorse, but it can also become a costly benchtop ornament if the speed range, timer, or positioning system don't line up with your actual workflow. In my experience, the sweet spot for a laboratory shaker is that it should be flexible enough for routine cell culture plates, sturdy enough for heavy glassware, and smart enough to integrate with automated sampling rigs without turning your bench into a maze of cables. The HS260 is marketed as a control laboratory shaker with positioning point, which immediately tells you the manufacturer is aiming at labs that already have, or plan to have, a robotic sampling arm. The integrated endpoint positioning is essentially a metal plate that the shaker can move to a predefined spot, allowing a robot to dip a probe or withdraw a sample without you having to manually reposition the whole platform. If your lab runs a high-throughput assay where a liquid-handling robot pulls aliquots from multiple flasks every few minutes, that feature can shave minutes off each run and dramatically reduce the chance of a missed sample. On the other hand, if you're a small academic lab that only needs to shake a few 50 milliliters conical tubes a couple of times a day, that positioning point might be overkill. You'll still get the basic shaking function, but you'll be paying for a capability you'll never touch. That's where the value conversation starts. Let's talk about the day-to-day usability. The digital display is clear and reads speed and RPM, timer countdown, and the current mode without needing to press a menu button. In practice, that means you can set a 30-minute incubation at 150 revolutions per minute, walk away, and come back to see exactly where you are in the cycle. The time-switching clock is electronic, not mechanical, so you won't be fighting with a winding knob when you need to change the program on the fly. I've seen labs where a technician forgets to reset a mechanical timer and ends up overshaking a culture. The electronic version eliminates that human error. Speed range is another practical point. The HS260 covers a fairly broad band from low-speed orbital motion suitable for delicate cell cultures up to higher speeds that can keep a suspension of beads in solution. In a real-world scenario, I used a similar IKA model to keep a yeast broth in gentle motion for 48 hours at 50 revolutions per minute, then switched to 200 revolutions per minute for a short vortex before sampling. The transition was smooth, no sudden jerks, which mattered because the cells were sensitive to shear stress. If your protocols require that kind of fine-tuned speed control, you'll appreciate that the motor can be dialed in increments rather than jumping in big steps. Now, what are the practical downsides? The biggest hidden trade-off is the footprint. The dimensions of the unit are roughly the size of a small desktop printer, but you still need enough clearance around the sides for the positioning plate to move without hitting other equipment. In a cramped bench space, you might find the shaker's range of motion limited, which could force you to rearrange your layout. Also, the integrated positioning point requires a compatible robot interface. If you later decide to switch to a different brand of robot, you might need an adapter or even a firmware update, which adds an extra layer of complexity you didn't anticipate when you first bought the unit. Another point worth noting is the cost versus alternatives. There are lower-priced shakers that can hit the same speed range and have digital timers, but they lack the positioning point. If your lab already has a robot, the extra expense can be justified because you'll avoid buying a separate positioning platform. If you're buying the shaker as a standalone piece, you might end up paying for a feature you'll never use, and a cheaper model could give you the same shaking performance for a fraction of the price. Who should buy this? If you're running a medium to large research facility with an automated workflow, think drug screening, enzyme kinetics, or high-throughput fermentation, the HS260 slots in nicely. The ability to program a precise shaking profile, combine it with a timer, and have the platform pause at an exact point for a robot to sample can streamline the whole process. It also makes sense for quality control labs where reproducibility is non-negotiable. The digital readout ensures every run is set identically. Who should skip it? Small teaching labs, hobbyist biologists, or any setting where shaking is occasional and manual sampling is the norm. In those cases, you'll likely get more bang for your buck with a simpler shaker that has a sturdy